In this video, we're going to talk about formulas, and more specifically, how to solve a formula for a specified variable. We use the term formula in math a lot, but what do we really mean by formula? Well, a formula is any mathematical relationship or rule expressed in symbols. So we can use formulas to convert between degrees Celsius and degrees Fahrenheit. We can also use formulas to find the perimeter of a rectangle. To solve a formula for a specified variable means to isolate that variable. In other words, get that variable on one side of the equation and all other terms, variables, and numbers on the other side of the equation. If we look at our first example down here, we see that we have the formula V equals LWH, and in this case, this formula is said to be solved for V because V is isolated on the left and everything else is on the right. Now, in order to solve a formula for a specified variable, we're going to use both the addition and multiplication properties of equality to get that variable isolated on either the left or the right side. So let's look at our first example. We want to solve the following formula for H. Well, the first thing that we have to do is identify how many terms in the formula contain the variable H that we're solving for. And then we need to make sure that all of those terms that are containing H are on the same side of the formula, and everything else is on the opposite side. So if we look here at our first example, we have V equals LWH. Well, remember that when variables are sitting side by side, that simply means multiplication. So the only term that contains the variable we're solving for is the LWH on the right, and it's already been isolated from all other terms, which in this case is just the V on the left. So we don't have to worry about the addition property of equality in this case. However, we do still need to isolate the variable H. And in order to do that, that means we need to get rid of the L and the W. Since the L, W, and H are sitting side by side, that means that all three are being multiplied, because remember, variables that are written side by side with no signs between them are implied to have multiplication as their operation. So we need to divide both sides by L and W to get rid of the L and W on the right and isolate the H. So multiplication property of equality says if we do it to one side, we have to do it to both sides. So on the left, we are left with V divided by LW. Notice we can't actually divide V by LW, but we can indicate that division. And then on the right-hand side, the L's divide out and the W's divide out, and we're left with just H, which is what we wanted. We wanted H on one side, all by itself, and everything else on the opposite side. So we can now say that this formula has been solved for H. One thing I do want you to note is that we keep the same case throughout when we're working with a formula. So since the V was uppercase originally, it must remain uppercase throughout the entire solving process. Just like L, W, and H were all lowercase initially, we must keep them lowercase. We will work with formulas from time to time that contain the same variable twice, but one will be representing the uppercase and one the lowercase, and there'll be two different values. So it is very important that we don't change the case of our variables as we're solving. All right, so now let's look at another example here. So we have 2x plus 3y equals 4, and we want to solve this formula for y. So again, the first thing we do is look for how many terms contain the variable that we're trying to solve for. In this case, we only have the one term, 3y, that contains the y. However, unlike our previous example, notice that it is not on one side by itself yet. It's over here on the left with the 2x. So the first thing that we have to do is to get rid of the 2x or move the 2x to the other side using the addition property of equality. So since the 2x is positive or has been added, we're going to do the opposite and subtract it from both sides. So we're going to subtract 2x. On the left, we end up with 3y, and on the right, we end up with 4 minus 2x. So now we have the y term isolated, but now we need to get the y completely isolated. So what's still been done to the y? It's been multiplied by 3. So we're going to use the multiplication property to do the inverse operation or divide both sides by 3. The 3's on the left cancel out or divide out. And then on the right, we have 4 divided by 3 and negative 2x divided by 3. So don't forget that when you're dividing, you have to divide every term on both sides by that same number. So a lot of times people will divide the 4 by 3 or the 2 by 3, but not both. But remember that we must divide every term by 3. So we can now say that this formula has been solved for y since y has been isolated.